thing that got me initially interested in engineering was
fictional characters like Tony Stark building all this cool stuff.
I guess I kind of just always liked building stuff.
I had this thing called snap circuits, so I would just like make circuits and stuff.
I taught myself how to solve like the Rubik's Cube.
There was a vacuum cleaner at my grandparents' place, and I took it apart.
And I just was like building things a lot with my hands, and so
That's kind of what got me started into engineering.
So engineering is 100% solving problems. We teach breaking down big problems into as small and manageable a chunk as possible, and then knocking down those dominoes one at a time.
The first part about making any project is envisioning what you want it to do. I'm making a bear feeder right now, so the Oregon Zoo might want to use it to feed their bears because they don't want humans to be associated with feeding the bears. So they asked for someone to make a machine that would spray the treats without associating treats with humans.
basically the idea I came up with was like a robotic color, and then it has to be controlled by something. So I used a color sensor right here to control it. So depending on which color it senses, it will do like a different motion. I coded yellow just to like go forward, like very slowly. The opposite, red goes backwards. Blue will kind of like go forward and like turn.
Currently, we've been building a hovercraft.
Using 3D printed parts and putting the electrical stuff in there and just testing it out, making it work.
When we first got the motor, it wasn't working at all. So at that point, what you gotta do is you gotta like try to do it yourself.
When I model things, they work perfectly, but in real life, they don't always work out, and that's one of the reasons we have to test a lot.
Teaching myself how to do certain things is probably the biggest thing I've learned from this class. I feel like it's applicable in like every environment, but especially engineering, where you have to be the one to like break ground and like do all the new stuff. So it's really cool.
So tic-tac-toe is a relatively simple game, and there have already been several algorithms created that can allow a computer to win every single time. But rather than simply picking an algorithm that's already there, I did a bit of research into how AIs are made for games in general, and I tried designing one on my own, and it actually has multiple different difficulty levels. Here it's on the hard mode. If I start a game, the other player always makes the optimal move. So in the hard AI, it's able to win every single time, and when it doesn't, that's because you're playing just as well and you hide. The idea of being able to program something to work just as I want it to is much nicer than winning a game of tic-tac-toe. So not being able to beat the AI is fine. No one can. I'm not the only one.
3D printing can involve a lot of different things. So there's PLA, which is turned into filament. It's plastic, which basically is ran through, and it's kind of densed down and then turned into really thin lines of plastic, where we use to print stuff like this.
So this is a drone for the Advanced Engineering drone class. We used a lot of 3D printing and then some laser cutting, so you can kind of see that the arms and where the arms slot in are all 3D printed, and then we laser cut all the plates out of acrylic, and then that all screws together and just kind of makes a really rigid, kind of stable frame. We're all still in the design and testing phase, so we've finished all like the hardware stuff, and so now we're just setting up the software side of things to get them ready to fly.
One thing that I really enjoyed was the fact that they have a female engineering teacher. As someone who is a minority in the engineering pathway, it's really nice to be able to like have someone to rely on.
It makes me very happy to be in here, and it's a very welcoming and warming atmosphere. It's something I'm really gonna miss about this school, because I spent a lot of my freshman year being bullied, and it was not fun, and that's part of the reason why I didn't want to come back. So when I came back, it was a much nicer, more welcoming feeling to be in this classroom and talking to Mr. and Mrs. Gear, because of just how good they are as people. That's just nice. It's nice that I can be an example to students who might not feel like they're seen or heard.
And I think this program has like truly blessed me. It's been an amazing opportunity to learn and play with all these different types of instruments.
Just to be a high schooler and walk in school, you have 3D printers, laser cutters. They trust you with being creative and making your own stuff.
Yeah, I definitely feel a lot more prepared because I know a lot of people don't have the opportunity to go to classes like this before they go to college for stuff like engineering, and I feel like this really gives me a solid foundation to keep moving forward.